Hello again. Today we're doing chapter 9.5, which is multiplication, and we're going to start off with some rule of signs. The first one that we're going to go over is a positive number times a positive number, which we've been experiencing for a long time, and it always gives us a positive. The next one that's a little bit funky for students is a negative times a negative. And the best way I could describe this one is to kind of talk about it in English sense, where maybe I were to say, I don't not love my husband, which is crazy. I'm married to the guy. Hopefully I would like him. So when you think about it, I said don't not. So I have a double negative, which really in English sense turns it into a positive. So a negative times a negative is a positive. Pretty much when we have the same signs, both for positive or both for negative, our result always is a positive. Now things change a little bit when we have different signs. Maybe a negative times a positive, or a positive times a negative. Now there's only one negative involved, just like in the English world, when there's one negative, it makes the statement negative. So when we have different signs, the result is negative. And if we can keep that in the back of our mind, we're safe. So what we're going to do now, instead of multiplying nice integers and whole numbers, we're going to go ahead, and multiply decimals together, just for old time's sake. So let's say we had a question that said 2.4, negative 2.4, times 3, and we had to multiply these guys together. Now, if you forgot, this is how we multiply decimals. We pretty much pretend there is no decimal point, and we multiply as usual. Notice I didn't include my sign. I kind of just dropped it off. I'm going to ignore it for now. I'll save the signs to the end. It won't be too bad. So we'll do 3 times 4 is 12, carry the 1. 3 times 2 is 6, plus the 1 is 7. Now we'll pay attention to the decimal point. There's only one of it, so we'll move our decimal point over 1. My decimal point got crazy, so I got 7.2. But now we got to make sure we're careful with our signs. I had a negative times a positive, so my final answer should be negative. And that's what you can pretty much do when you multiply. You can save the signs for the end, or you can do it right away in the beginning if you're worried you're going to forget it. Let's see one with fractions, similar to that. We have negative 4/5 times 7 over negative 8. So let's say you're one of those people who are like, I always screw up my sign. Let's take care of them right now. We have a negative number times a negative number. Notice there's 2 negatives, no other negatives anywhere else. So a negative times a negative gets us a positive. Now we can pretty much ignore the signs. Don't even worry about them. You've already written that your result should be positive, so we'll continue on. With fractions, there's a couple different ways you can do this. You can multiply straight across, then simplify. Or simplify first, in which you see 4 can go into itself and into 8 twice. And then multiply across. So you get 7/10. And it's positive 7/10. And there's our answer. Now, the next thing we're going to tackle is exponents, which is really repeated multiplication. We're going to start off nice, in which we're going to describe 2 to the 5th. Now, I read that a very special way. That little exponent, it's a superscript. It's floating above my base. So 2 is what we call a base here, and 5 is what we call the exponent. And sometimes people will refer to exponents as powers. In fact, I tend to choose power as my word. I like to say power of. Sounds more imposing. So we have 2 to the power of 5, or 2 raised to the 5th power. What this means is that we have 2 times itself 5 times. So it's repeated multiplication of whatever the base is. Oh dear. And It's the same thing, sorry about that. So it's repeated multiplication of whatever the base is, and the exponent tells you the number of times it's repeated. And if we wanted to simplify or evaluate this, we just got to multiply it all together, in which we can do 2 times 2 is 4. Oh, hey, look, 2 times 2 is 4. 4 times 4 is 16, times 2 gets us 32. So we have 2 to the 5th equals 32, which you might find a little bit interesting if you wanted to look into this. Look into 32-bit for the computers. And 2 to the 5th is describing our binary code that computers are dependent on. So if you're interested in some fun computer science facts, I would definitely recommend Google searching this and looking into the 2 raised to a power. Definitely very interesting. So to get back on to our track, let's go ahead and write it once more. We always have a base, and it's raised to some power or exponent. And I'm going to abbreviate exponent just for sake of time. Let's go ahead and talk about how we read some of these. And I'm just going to choose a random base, x. And the first power or exponent that we work with is 1. And x raised to the 1 is just x times, 1. There's nothing else going on there. It's just x by himself, because there's only x repeated multiplication 1 time. Well, here he is. So that's kind of boring, and how we would read that is we'd say x to the first power. Or you could say x raised to the first power. It doesn't make a difference. One of our more unique ones is x squared. And you can already tell I read it a little bit differently than what we've been saying, in which we have x times x. So how we read that is x squared. Or we have another bit of a fancy way to describe it. We can say x raised, or to the power, raised to the second. So whichever you prefer. You could say either or. Just don't say x2. That's confusing to me and doesn't really make much sense, okay? So the next one we have is x cubed, which means x times x times x, and you're probably getting bored, so let me just write him, and he's one of the last special ones. So I made a boo-boo, let me fix that. X cubed. You could also say x raised to the third. After the x cubed, it's x to the 4th, x to the 5th, x to the 6th. They don't have special names, at least not that we call them by. So there's our general gist. Now, with this, we have a little bit more funky business to tackle. And that is the opposite of x squared and negative x squared. Squared is very particular with negatives being involved. In fact, all even exponents are very picky about that, and we'll expand on that further. So, opposite of x squared. The way this guy is being read is saying we have the opposite, so changing the sign, usually a negative does that, of x squared. Negative x squared is read much differently. We read that as negative x, that thing being squared. Now you might be thinking, that's the same thing, Miss B. It does not change it. Well, let me give you an example. Let's say I have the opposite of 3 squared. The way this is really read is we have negative 1 times 3 squared. Well, 3 squared is 9, and we have negative 1 times 9, which gets us negative 9. Now let's go to negative 3 squared. Read very different, so it's put into parentheses. Since it is in parentheses, this is read as negative 3 being multiplied by itself twice. And negative times a negative is a positive. Changes the answer greatly. Okay, now with this, we can devise some cool exponent rules. And the first one I'm going to tackle, we're going to keep our numbers nice and easy. Let's say we have negative 1 squared. So this means we have negative 1 times negative 1, which is positive 1. Whoopie-doo. So now I'm going to get a little bit crazier. I'll go to the next exponent, -1 cubed, which means we have -1 times -1, and you can always skip forward if you're tired of hearing me yap. And we have negative times a negative times a negative gets us a negative. There's negative times a negative is a positive. Positive times the negative gets us a negative. Not too bad. So let's see. We have -1 raised to the 4th, and you can kind of already guess what this one's going to be. We have -1 times itself 4 times. There's an even number of negatives, right? 1, 2, 3, 4. Negative times a negative is a positive. Negative times a negative is a positive. And we're multiplying a positive times a positive, which gets us a positive. So what's coming out here is whenever we have a negative included in these parentheses, that's the important part, raised to an odd power, our result is negative. But notice it's just what's inside the parentheses being raised to the power. If there's anything out on the outside, it'll change our answer. So just be careful. This is just a special case of a rule. The next one is if we have an even power, and that's like 2 and 4 here, we have an even number, our result is always positive. So we'll say is positive. So if I were to be crazy and ask you a question like -1 raised to the, I don't know, I'm going to give you a crazy number. Whoops. Oh, I'm tapping something. Hang on. Okay. For that, I'm going to give you a worse number. Okay, so let's say that's our number. We have 15,763,212. And you're probably thinking, oh my gosh, I can't write out -1 that many times. My hand would fall off. And you're right, don't do it. What you're going to do is look at the last digit of the exponent here. Is it even or odd? It's even. Well, a negative raised to an even power, and 1 times 1 times 1 is still 1. So we have +1. There's our answer. Pretty nifty. And let's get drastic here. Let's say I had, I don't know, 2005. Alright, well, looking at the last digit, it's an odd number, so our answer should be -1. Now, we can't do that with anything except 1. 1 is nice because 1 times 1 is 1. But as soon as we change this number to maybe 2, 2 times 2 is 4, times 2 is 8, oh my gosh, it gets crazy. So only one that's special is 1 that we can do this nice little rule for. But we can keep it in the back of our minds when we have larger exponents for negative numbers that are not 1. Just something to keep. And then the last thing we're going to cover here is a little problem that asks us to evaluate, in which we have -x squared and the opposite of x squared, when x is 9 and x is -9. Just to give us a more in-depth picture of how the negative being included in parentheses versus on the outside changes our answer. So this question is asking a lot of things. Let's start when x equals 9. So the first one we'll evaluate is -x squared. So really, we have negative. Instead of x, we're going to plug in what x equals, which is 9. So we have -9 squared, which really means -9 times -9. A negative times a negative is a positive, and 9 times 9 is 81. And we could even see that. We have a negative raised to an even power. We should have a positive. Now that's just the first one. Let's do x equals 9 for the opposite of x squared. Now this one reads differently. We're reading this as the opposite of x, whatever x may be, squared. And I'm going to write parentheses here for x, because only the x part is being squared, not that negative. He's on the outside. So only the 9 is being squared. So we really can read this as -1 times 9 squared. 9 squared is 81, so we have -81. And you might be thinking, okay, we're done, let's end this. Not quite. We still have to do the same exact steps for when x equals -9. So if you want to pause, give it a shot, try it on your own. I'll give you a quick second. and I'm going to start it over here. So x equals negative 9. So we have first negative x squared. So when we plug this in, we have negative x squared. X is negative 9, so it looks really ugly. Now we have to simplify inside these parentheses a little bit first. We have a negative times a negative, which is a positive. Two negatives make a positive. So really we have 9 squared. And 9 squared is just 81. Kind of funny, right? It's actually the same answer as before when x was 9. Because it's included in the parentheses, whenever we square something, doesn't matter what craziness it's inside, it always results in a positive. And that's what happened here. And now we'll do the same thing for x equals 9. Oop, I'm sorry. I'm jumping the gun. I didn't finish x equals negative 9. I'm sorry. We have now the opposite of x squared. So this is equal to the opposite of x squared. X here is negative 9. This negative 9 is included in being squared. So we can't actually take this negative on the outside and mess with it. We got to work with this exponent first. If we were to write out what it really means, we have negative 1 times this thing. So we have negative 1 times negative 9 times negative 9. You have an odd number of negatives. There's 1, 2, 3. So our answer should be negative. And 9 times 9 is 81. And we have negative 81 for our final answer. And that is all.